Hello all, as a continuation of my lecture series in special electrical machines, now I am going to discuss about the principle of operation of PMBL DC motor. So in already posted videos, I have already discussed about the introduction to special electrical machines and a brief application oriented topic about all the 5 motors which we are going to discuss in the upcoming classes. So in this video, I am going to discuss about the principle of operation of PMBLDC motor. So coming to construction of permanent magnet brushless DC motor, in the previous videos we have already discussed about the types of magnets and what is the difference between permanent magnets and electromagnets. So as all the motors have, here we have two main parts, stator and rotor. So stator is made of silicon steel stampings with slots, and the slots are accommodated with armature windings, and the windings are wound with specified number of poles, particularly it will be an even number. So this winding is connected with the DC supply through power electronic switching circuits. So those power electronic switching circuits are used here for the purpose of electronic commutation. Rotor accommodates permanent magnet, and the rotor shaft carries rotor position sensor to know the position of the rotor so that the pulse can be generated for that particular purpose. So the sensor provides information about the position of the shaft, and the shaft position signal is sent to the electronic commutator. So by this, these are all the parts that are needed in order to construct a permanent magnet brushless DC motor. So commutator in a DC motor. So this is the structure of commutator. The purpose of commutation is, it is a process of switching between the phases, and which is called as commutation. We have two types of commutators. One is mechanical and another one is electronic. This mechanical commutator is used in the brushed DC motor, and electronic commutator is used in brushless DC motor. So coming to mechanical commutator, so in the picture it has two poles. It consists of two poles and 12 commutator segments, which is shown in the picture, and we have two brushes A and B. So the A and B are supplied with the external supply. So when DC supply is connected across A and B, the current passes through the commutator segments. So the commutator segments, either it may be clockwise or anti-clockwise. So either it may be from point 1 to 7 or from point 1 to 7 in the counterclockwise way, like 12, 11, 10, 9, 8 and 7. So there are two paths for the flow of current. Either it may be from 1 to 7 or it may be from 1 to 7 in the counterclockwise direction. Coming to electronic commutator, so here the commutator segments are not there. Instead we have a drive circuit, so which consists of switches. So 12 switches and So first let us consider the switch S1, and S1 dash is closed. So if S1 is closed, the positive DC supply from A passes through the field winding and closes through S1 dash to the point B, so that the current starts to flow. So here also we have two path currents, 1 to 7 and 1 to 7 in the anti-clockwise way. So this operating switches in a sequential manner creates the magnetic field. So this is about electronic commutator. So this is a difference between mechanical commutator and electronic commutator. So mechanical commutator is a commutator made up of commutator segments and mica insulation. Brushes are made of carbon. Whereas in electronic commutator, it is fully because of the power electronic switching devices which are used in the commutator purpose. So coming to mechanical commutator, shaft position sensor is not needed, whereas in electronic commutator it requires a separate rotor position sensor to sense the position of the rotor and change the pulse. And in mechanical commutator, the commutator arrangement is located in the rotor, whereas in the electronic commutator it is arranged in the stator. And sliding contact between commutator and brushes, here no sliding contacts because both commutator and brushes are not they not in the be a brushless DC motors. So electronic commutator, there is no purpose of brush and commutator. Sparking takes place, there is no sparking in electronic commutation, and it requires regular maintenance for mechanical commutator, whereas the maintenance is less in electronic commutators. And the number of commutator segments are very high in mechanical commutator, whereas in electronic commutators we have switches, number of switches which is limited to 6. And difficult to control the voltage available across tapping, and here there is no difficulty in controlling the voltage since we have PWM techniques or vector pulse width modulation techniques. So we can use some technology oriented things in order to control the voltage. And mechanical commutator is highly reliable, whereas electronic commutators its reliability depends on the switching devices. So in this video we have discussed about the commutator and the difference between the mechanical and electronic commutator and its commutator segments and how the current flow will be and where the commutator will be used. So we will see in the next video. Thank you.